Okay, so let's get to the work. So the question says, consider again. I want to write out the question. The question says, consider again. Consider again the random variable described in problem, the random variable described in problem with a cumulative distribution, distribution function of f of x equals to x squared over 16. So the rest of the question you would see on the screen, or since you see the rest of the question is already a thumbnail, so you should see that from the thumbnail. So the next thing is that we get to the solution to this. Before the solution, so let me just complete the question. For f of x equals to x squared over 16, for 0 is less than or equals to x, which is less than or equals to 4. So question 1 is, what is the expected value of this random variable? Question B is, what is the median of this random variable? So let's get to the solution right now. So the solution now is that as discussed, the cumulative distribution function, sorry, if you can see this, is f of x is x squared over 16, right? So what we are expected to do is that we have to find the probability density. So probability density function, by differentiating the distribution function. Okay, I just want to write this on another line. By differentiating the distribution function. So that we have f of x. I hope you can see it clearly. So that we have f of x equals to partial differential of f of x over dx. So I just have to make this, I want to turn it so that the size of the paper will be enough. And I'm going to rewrite it, f of x equals to the partial differential of f of x over what? Dx, which is same as what? 2x over 16. Therefore, the probability density function of a random variable x, is given by f of x. There's an extensive bracket which is x over 8. 0 is less than or equals to x, less than or equals to 4. So 0 otherwise. Okay. So we are still on it. We are not yet through because we have to go to the next question. Now, step 2 says this. We want to consider step 2. Now we have to calculate the expected value of the random variable. We have to calculate expected value of the random variable x. I hope you can see it. So I have my x to be the integral of 0 to 4 x f of x dx, which is equals to the integral of 0 to 4 x over 8 dx, which is equals to the integral of 0 to 4 x squared over what? 8 dx, which is equal to 1 over 8 into s cubed over 3 with your limit here. So we have, so that's when you put 4 into this x, when you substitute the values of x to be equals to 4, then we have 4 raised to power 3 over 3 times 8. Now, 0, anything divided by 0 is still 0, so it is insignificant. So the answer here is 2.67. So the expected value is what? Is 2.67. Now, the next thing we want to do now is to find or to calculate the median of the random variable. The median of the random variable. So that the f of m equals to what? 0.5, which implies that what? M squared over 16 equals to what? 0.5. And this implies that what? M squared equals to 8. So I have m to be what? Root of 8. So therefore my median is what? 2.83. So the median of this random variable is 2.83. Now, I'll just try to introduce myself again at the end of this video. My name is David and I help out in solving random questions. I ask people all around and we come together to try to solve it together, and at the end of the day I make videos on it. Thank you. And if you haven't subscribed, please subscribe, because if you subscribe, you'll be able to get more of videos to the problems you have. And if you have any problem, you can send it on the comment section. Thank you. Hey, how are you doing? I hope you're doing well. Okay, I'll just try to introduce myself so you can get to see the face behind this video. My name is David and I try to help out in solving random questions. However, I don't do this with my own knowledge alone. I ask. There's extensive research from friends, from families, and some educationists. So I try to make videos on it. So, and the name of this channel is called Bravo Light. And if you have more problems, please kindly send in the comment box, and I'll be expecting you. And please, if you haven't subscribed, please subscribe.